So good evening, friends. Today is the first day of the workshop. This workshop focuses on the basic statistical methods, and we will use SPSS software for demonstration of these tests. So today is our first day. So this session is based on the interface of SPSS. So I am sharing the PPT. The PPT and the dataset will be available in Google Drive. Today, we will discuss about the interface, the data view interface, variable view interface, and how we can feed the data in the SPSS. And after feeding the data set, how we can go with basic analysis like frequency distribution, cross tabulation, descriptive, outlier testing, and normality. So the whole content may not be covered in single day. It may be continued to the next session. Okay. So when you open the SPSS, this is the front page, and let me open the SPSS also. So you basically search the SPSS here. I hope you can see the search, and IBM SPSS Statistics 26 app is visible. You just click on it. When you click on it, SPSS will open. So this is the way we can open the software. It is a product of IBM. Earlier, SPSS was an individual company, but later on it was acquired by IBM company. So it is a now product of the IBM. Initially, this page will come. So you just cross it. And when you open this page, first of all, check here in the bottom, IBM SPSS processor is ready. So maybe you can see in this section, IBM SPSS statistic processor is ready. So this ready word should be there. By chance, if this ready word is not there, it means your installation is wrong. So you have to reinstall, or you have to take some corrective action to install this properly. So first of all, check this, whether it is ready or not. After that, then the second thing you need to check is, you can see the data view and the variable view. So there are two options here. One is the data view and second is the variable view. Initially, we have to define the variables and then we will go to the data. So first of all, click on the variable view. First of all, you have to click on the variable view. So once you click on the variable view, you can see the different options mentioned here. And it is important to understand each and every option. Number one, the first option is name. So it is a variable name. Like for example, the first variable name is name of the respondent. Suppose you have two words, like for example, name of company, let's say. So in this name, this space is not allowed. So you cannot put a space between the two words. If I do this, the software say variable name contains an illegal character. So whenever you got this problem, it means you by mistake you gave the space between the two words. So here you can use dot or the underscore to join two words. Like I can write name underscore company, or I can write name dot company. So you can connect two words by underscore and dot. So this is the way we can define the variables. So let's say my second variable is gender, age group, income group. So I'm just randomly creating the name of the variable. Then I have grades, then quality, satisfaction, and the price. So in this way, we can create the variable names. Second things come, second column. I think first column is clear. First column is the name, and the name should be short. So never write the complete very big variable name. Variable name must be short. And the detailed of the variable name you can put in the label. Like for example, it is price or satisfaction. So you can write here satisfaction level of customers. So detailing of the variable comes in the label. This is grades in graduation. So we can write like perceived quality. So in label, you can write the detail of the variable. And when you apply some analysis, whatever you write in the label, that comes in the output. Remember, variable name never comes in the output. Whenever you run anything, only the label comes in the output. So designing the labels is very important rather than designing the variables. Number two, the second column is type. 99% of the variables in SPSS are numeric. So if you click on this box, basically in the right hand side, if you click, the box will come. If you click, the box will come. If you click, box will come. So by default, you can see by default it is numeric. By default it is numeric. But suppose if you want to write the name of the company, company cannot be numeric. So you can put the string. String means alphabet. So I am putting name of the company in a string and all other numeric. So 99% of the variables or 99% of the variables in SPSS are numeric. We cannot apply any test on alphabet. We can only apply test on numbers, numeric. So remember that. So all the variables should be numeric. Even if a single word is alphabet, if in the variable, if you have even a single observation as alphabet, software will not take that. So remember, it is a numeric. Now the third is width. So what this 8 represent? What this 8 represent? I'm giving you one example. Suppose I have a company name Reliance. So you can see that I cannot type beyond that. I cannot type beyond this. Why? Because there are 8 characters into it. RELIANCE. So I cannot type anything beyond that. So because you are saying that only 8 characters are allowed to type. Similarly, suppose price. The price in number we are not having any problem. I can write many numbers. You can see, but when I type the alphabet, software will not take more than 8. So if I want to type a big name, so I have to increase it. Now I can write like Amitabh Bachchan. So I can write, right? The moment I decrease it, so you can see that only Amitabh is coming, Bachchan is removed. So the concept you need to remember is the width means number of the alphabet you need in the variables. So whenever you feed the data in this variable, how many alphabets you need? So that is the number. So I hope it is clear. How many alphabet you require? 8, 9, 10. That is fine. So you can increase as per your choice and you can type after that. So in this way, you can write the name of the company. Then we are having the decimal points. So how many decimal you need? You have to indicate here. For example, my price is having 2 decimal. If I put 400, the software take 2 decimal. If I take 600, 6000, the software is taking 2 decimal by default. You can increase the decimal or decrease the decimal. Now the question is that how many decimal we require? If you, in case of nominal scale category, in case of orders, in case of Likert scale, actually no decimal is required. If you are collecting the data from questionnaire using the Likert scale, decimals are not needed. But if you have data from finance, asset size, exchange rate, then ideally 4 decimals are required. So you can keep number of decimals as per your requirement. If it is not required, like for example, in quality, perceived quality, no decimal is required. So I can put it 0. So I can put it 0. So whatever I type in quality, you can see that decimal is not taken by the software. So I hope it is clear. After that, label means in questionnaire, you have a long sentence items. So these statement comes here and the item codes comes here normally. So service, the statements always comes in the label and the statement codes should come here. So I will show you many files where the labels have the statements, long statements, and variable names are very short. After that, we are having the values, the most important option in the SPSS, like for example, gender. So if you click on this right hand side, the software is asking for the values. In normally we give 1 to the males. 1 means male, add, and 2 means female, add. So you can define the categories. Similarly, age group. I can say 1 means less than 30 years. 2 means 30 to 45 years. 3 means more than 45 years. So we define the values here. Similarly, I can go for income. So less than 5 lakhs. It is as per your choice, but whatever comes in my mind, I'm just putting it. 5 to 10 lakhs. 3 more than 10 lakhs. So this is the work, this is the objective of values. So you can define the categories here. Now, the next is the missing. Normally, data should not be missing, ideally from professional aspect. I'm telling you, we should not have missing values. And now most of the data are collected by Google Forms. So in Google Forms, we are having a option that this question is required. So nobody can submit the questionnaire without filling it. So nowadays, the importance of this missing option is going down, and we try to keep that no observation should be a missing observation. And if any observation is missing, that we have to fill it. Okay. So missing means I just say professionally that missing value don't require. We don't need missing values. And if you have the data, and in the data, we are having some options to remove the missing observations. You can see that in the transform, in case if we are having the missing values, we can replace missing values by different options. If you go to the missing values, send the variable here, and you are having different options here. Series, you can replace missing values by the series mean, mean of nearby points, linear interpolation, linear trend. But ideally, we don't have missing values here in the data set. After that, column. So this is not very, very important because this is actually this width. If you decrease it, this width will come down. If you increase it, this width will increase. So from a professional point of view, this column is not important. After that, we are having alignment. By default, number you can see they are on right aligned. So 3 comes on the right hand side, 4 comes on the right hand side. So the alphabets are left aligned by default, and numbers are right aligned. If you want, you can change it, but I prefer not to change this option because we are having a habit of watching the data set right aligned. So we never change this. Then we are having the measure. I hope you understand alignment. Alignment is simply when you go to the data view, you can see that it is coming on the right hand side. And if you just to show you, if you put it left, it comes on the left hand side. If you put it center, it comes in the center. So this is just the alignment. So take it right. After that, we are having type of data. So there are three type of data set: nominal, ordinal, and if you click on it, scale. Nominal means categories: male, female category, age group is a category, income group is a category. So nominal means category. Ordinal means the order, like grade, preference, rank. So anywhere if you apply the rank, any variable where rank is meaningful, in that case you can call it ordinal variable. And if you are measuring the data with the help of a Likert scale, or it is measured in any unit like weight, kilogram, price, rupees, then it will be a scale. Most of the data set we are requiring is actually scale variable. So whether your data is ordinal or scale, you have to mention that. So by default, these variables are scale. So I'm taking scale. Income group is a nominal. Grade is ordinal. And age group is nominal. This is nominal. So we are having type of data. In the last, it is a new feature of the SPSS. So you can define that which type of variable you are having. Target variable means dependent variable. If you feel any variable as a dependent variable, like suppose I say that satisfaction is my dependent variable, I can define it as a target. So target means dependent variable, and all other variables are input variable, means independent variable or input variable. So not much of use. In this way, we can define the variables initially. And in the top, you can see we are having the file, open the file, save the file, edit, view, data, management. All the options that we use to manage the data is here. Transform, when you convert data formats. Analyze, all the analysis comes here. Graphs, any utility, extension, window. So these are the options that we are going to use in coming days. So this, after feeding the data, once you define all the variables in the data set, the next step is to go to the data view. Here you have to fill the data. So I'm just showing you some basic data set, like so whatever comes in my mind, I'm just showing you. Then we have TCS, Infosys, Wipro, Hero. So this is the way we can feed the data. Gender is only 1 and 2. And age group is also, we are having 3 groups. And income group is also coming like this. Grades and satisfaction level. So in this way, you can fill the data. But frankly speaking, in older days, when we have the filled questionnaire, during that time, we fill the data like this. But nowadays, we are getting the data from the Google form. And we take the data from the Google form actually. So in SPSS, there is a very good feature that you can import the data directly from the Excel or directly from the CSV file. So suppose you collected your data with the help of Google form. Then there is no need to fill all the entries manually. You just go to the file and you can see the import data, and you can import the data directly from the Excel or the CSV file. Suppose I click on the Excel, and if you have any file anywhere, so you can directly import that. So let me show you that. Suppose in the desktop, so I have some data set. Let me check. So I just click on the Excel file and the software will open the file within few minutes. So like you can see, the software is opening the data. So whatever data you have, the software open in few minutes. So in this way, we can import the data from CSV or Excel. So let me show one more example. So I'm just doing randomly import data, CSV data, and you can see that this case 3 is CSV data set, or data 1 is a CSV data set. You just click on it. Okay. And software will open the data set in few minutes. So this is the way we can open the data from CSV. However, in CSV, the major problem which is coming is that in Google form, you always have this alphabet. So most of the data you are having in alphabet. So you have to convert them into number. How you can do that? You can just go to data, sort, and suppose I want to take gender, convert gender. So after sorting, it is coming like this. So female is 2. So you can just copy or paste or whatever you want to do. So like that. Or in Excel, we are having the option of find and replace. So when you have an Excel file or CSV file from the Google form, you can do it initially there to replace, find and replace, and then import into the Excel, import into the SPSS. So in this way, we can feed the data set. So up to this point, I just tell you that how we can open the data set in SPSS. So now here we are having a data set, and gender after converting is now it is a numeric. So you can see it is a numeric. Age is also a numeric. PS, performance score, is a numeric. Monthly income is a numeric. So this is a numeric value. And in real, we got very huge data sets. This is a small data set, just to beginning. And later on, we will move to very large data sets. Okay, so just see what we have covered. So we have covered what is data view and what is variable view. So first we have to define the variables, then fill the data. You can also import the Excel data in SPSS. How we can, we already see that. And we have to understand the values, scales, types, etc. And we have to understand the variable names, the type of the variables. And I already explained you the meaning of name, type, width, decimal level. So these are some of the rules or explanation I mentioned here. what is name? This is just for your reference that you have to put the name of the variable. Space between the words are not allowed. Words can be connected using dot and underscore. So whatever I told you, I put here. Okay, so this is the explanation of the options. Okay, so I already explained you how we can create the variables in the SPSS. Now, after that, once you have the data set in the SPSS, after that, we need to analyze it. So the next step is for analysis. So how to start the analysis? So first analysis, which I'm going to show you, is the frequency distribution. So I start with here, frequency distribution, and basic thing before that. The first type of variable, we are having the nominal variable. So we have to understand the basic feature of these variables. Nominal variables is also known as categories, like male, female, young, middle, old, poor, middle income, rich. So all these are the categories, even married, unmarried, rural, urban, all these are categories. And just for example, suppose one means unmarried and two means married. Now the question is, can we say one is less than two, one is greater than two, one is equal to two, one plus two equal to three? So if you use your common sense, all these expressions are basically wrong. So nominal variables are those variables where you cannot apply any of the operators. So just for your further explanation, operations. So basically, we divide the operations into two categories. This is called relational and second is called arithmetic. And relational means greater than, less than, equal to, and this is plus, minus, multiply, and divide. So nominal variables cannot use either the relational as well as arithmetic. In every questionnaire, you are having the demographics like male, female, age, income, and all. So in all these variables, don't do that mistake. We cannot apply relational operators and we cannot apply arithmetic operators. Now the question is that if we cannot apply relational operators and we cannot apply arithmetic operators, so what we can do there? The question is what we can do. So we can do what we can do counting. So what we can do, we can count. So count means that how many male are there, how many males, that how many females. So the basic operation on the numbers is counting. And if you count different categories, like for example, we are having the income group, or let's say age group. So we are having young, we are having middle, and we are having old. So we can say that out of 100, 30 are young, 50 are middle, and 20 are old. Even in percentage, we can also show. So this representation is called frequency distribution. So the first analysis we should learn is to explain the frequency distribution. So for example, in this case, we are having gender, and we want to apply frequency distribution. So you can see this is the analyze option, and we are having the descriptive statistics, and the first option is frequency, and we are having gender here, gender, and do nothing, just click OK. So when you click OK, the answer will come here. The software is saying that 20 are male, 20 are female, and 40 is the total. So 50% of the people are male, 50% of the are female. Suppose I make some changes, like let's say one, I'm increasing the male, and in values, I say that one is male, and in two, it is female. And if I do the exercise it again, so analyze, descriptive, frequency, gender, male. So now the software is saying that 24 out of 40 are male, and in percentage they are 60%. 16% of the female of the respondent are female, number is 40. You can also make plots on that. How? Let's see. Go to analyze, descriptive, frequencies. Now you are having these charts. Bar chart, you can select only one chart at a time. So your bar chart will come. Your bar chart will come. And if you select pie chart, the pie chart will come. So this is a pie chart. And again, if you click on histogram, the histogram will also come. So histogram is also coming with normal curve. So this is simply frequency distribution. So I am creating one more variable just to show you that how we can make more frequency distribution. Let's say age group. So I am creating 3 age group here. One means less than 30 years to 32, or we should write 31 to 30 to 45, because it is less than, so 30 is not included. 45 years, and 3 is more than 45 years. So we are having 3 categories here, and I'm just putting randomly. Okay, So if I want to plot the frequency distribution of age group, go to Analyze, Descriptive, Frequency, Gender, Send back, select age group, click on this arrow. After this arrow, it will come here and select chart. Let's say pie chart and continue. And here you have to click on OK. So this is actually the frequency distribution. So 5 out of 40 belong to less than 30 years of age. 20 belong to 30 to 45 years, like that. So in this way, we can do the frequency distribution. In most of the research papers, this portion will come. It is almost compulsory to report the frequency and the percentage of each category in the research paper. So this table is very, very common to report. And if you want to increase the pages in the thesis, you can make this graph. And graph we can make also in Excel or in other softwares. Because we are having excellent softwares of making the graph. So we can make the graph using any other software. But analysis is very fine in SPSS. Okay, so I think we now understand what is the meaning of frequency distribution. So after that, frequency distribution is applicable only on one variable. Suppose you are having two variables or three variables, then you can combine their frequencies. When you combine the frequencies of two or more than two variables, this is known as cross tabulation. So what is cross tabulation? I am showing you. So let's say, go back to the data. I hope you can see the data set. Now I want to cross tab gender and age group. So now you can see the command. Every time we have to go to Analyze, Descriptive, then cross tab. In this case, we are having gender in the row, age group in the column. Anything which is having less number of categories, we put in row, and anything which is having large number of categories, we can put in column. If you want to show in graph, you can click on display clustered bar chart and do nothing, just click OK. So now see this. This is the male. Young people in males are very less. So most of the males are more than 45 years. You can see that green line is lengthy. So most of the males are more than 45 years. And most of the females are red, means more than between 30 to 45 years. So you can represent the data like this. Also, if you check this table, there are 24 males. Out of these 24, 2 belong to less than 30 years, 10 belongs to 30 to 45, 12 belongs to 45, more than 45, like that. So reading this table is very easy. And this table is known as cross tabulation. And actually, when we study the chi-square table, chi-square test, the chi-square test is totally based on this table. So in some session, we will study the chi-square test, and chi-square is built on this cross tabulation. Another point you notice, In this cross tabulation, we are having two variables, gender and age group. What happens if there are three variables? If you have three category variables, so can we make cross tab of three? Yes. So I'm showing you how we can make the cross tab of three. Go to analyze, descriptive, and cross tab. Now we have to think, because education is also a category variable. So we can put this in here. Age group I am sending to the first row, and gender I am sending to the layer 1 of 1. The rule is the most basic variable comes in the layer 1, and other second most important variable come to the row, and third most important variable go to the column, and just click on OK. So you can see we are having the 3-layer cross tab. Earlier cross tab was known as 2 by 2 cross tab. 2 by 2 means it is actually two variable cross tab. We were having gender and age group. In this case, we are having three variables. So it is basically 3-layer cross tab. So gender is number 1, male. How many male are there? 24. Female, how many female are there? 16. Total, we are having 40. In male, less than 30 years, 2. 30 to 45 years, 10. More than 45 years, 12. Similarly in female. And in 12 male, which belong to more than 45 years of age, 1 is having degree of BA, 2 BCom, 3 BE, 2 BSc, 5 BTech, like that. So this is the basic and the beginner's analysis of the cross tab. But this cross tab is found in most of the research papers, because if you have demographic profile of the respondent, you have to report it in the paper. So in this way, we can find out the cross tab and frequency distribution. So I hope up to this we are clear. Now we are moving to some other analysis. Okay, so frequency distribution and cross tab is clear. Then we are moving to the descriptive analysis. And believe me, it is the most important part. And you have to report this also. In thesis, it is also always compulsory to report the descriptive analysis. So what is descriptive analysis? First of all, I will tell you and then I will tell how to analyze that. So first, basic. Okay. So what is descriptive analysis? So descriptive analysis consists of 3 aspects. Number 1, this is called central tendency. Number 2, it is called dispersion. And number 3, this is called distribution. Okay. So these are the 3 aspects of descriptive analysis. And these are known as moments of the variable. Moment. In statistics, we call them moment. In central tendency, we include mean, median, mode, quartiles, decile, and percentile. So these are the components of central tendency: mean, median, mode, quartile, decile, percentile. In dispersion, we are having the minimum value, maximum value, range, standard deviation, and variance. We normally put these popular components in dispersion. And in distribution, we are having only two things. The first one is known as skewness, and second one is known as kurtosis. So these are the different components of the descriptive analysis. And believe me, it is very basic concept, but most of the researchers don't know the ideal value of skewness and kurtosis. There's a lot of confusion in this. And what is the meaning of standard deviation? And we also have standard error, important concept, variance. Then how to interpret this mean, mode, median. So we are going to discuss each and everything. So first of all, I am going to explain the central tendency. And I am going to tell you something which you don't know. Central tendency. The first is mean. And we also have a modified version of mean that is called trimmed mean. Most of you heard about this mean. Mean means average. Suppose you appear in 5 subject. If I ask you to calculate the average, you can calculate the average very easily. So this is x1 plus x2 plus and so on divided by 5. It is so simple. And if x, so it is repeated. So we are having other formulas. So mean is representing the average value. But the problem with mean is that, for example, if I ask you to calculate the mean average salary of an employee in a company, and suppose the salary is found to be 60,000. And if I say, remove the salary of the director or CEO from this. So what will happen? This mean come down to 56,000. So what happens sometimes after removing only a single person, the average is coming down drastically. So this is the problem of mean. Mean is highly sensitive to the outlier. So in statistics, to remove the dependency of mean from the outliers, we calculate trimmed mean. So what is trimmed mean? What is trimmed mean? Let me explain. Suppose this is the range. This is the salary of a peon, let's say 10,000. And this is the salary of a CEO, 10 CR. And both is having a problem. If you add this salary, the mean increases. If you add this salary, the mean come down. So removing the extreme. So we remove 2.5% from the left hand side and 2.5% from the right hand side. So whatever is left, if you calculate the mean of that, so this mean is known as trimmed mean. And believe me, this trimmed mean is very, very important in finance. Why? Because some stocks give you multi-bagger returns, some stock give you negative returns. So if you want to analyze the generalized returns, remove the outliers. So after removing the outlier, you will get more reliable mean. That mean is called trimmed mean. So I will show you how to calculate the mean and the trimmed mean. So after that, we are having two other concepts, median and mode. If you arrange the data in ascending order or descending order, the middle value is called median. The middle value is known as median. So this median is also known as positional average. So median is also known as positional average. So it is showing you the average with respect to position. So it is called positional average. So median is the middle value, simple. And the third value is called mode. Mode is basically, suppose if your data is like that, in this data set, the data is concentrated here. The data is also concentrated here. So this data is having two modes. This is mode 1 and this is mode 2. So what is mode? Mode means where the frequency of the data is the highest. Sometimes we are having the unimodal data. Unimodal data means you are having only this type of data. So mode is somewhere like this. So this is the variable which is having, this is the data which is having the highest frequency. Frequency means number. So the number with the highest frequency is called mode. So we define mode by two things: highest frequency or highest concentration. So if the observation is having the highest frequency, it is also known as mode, or where the concentration is highest, it is also known as mode. So mode will give you the value with high concentration. And after that, we are having the quartiles. If you suppose you are having the data and you divide the data into two equal parts. So this is 50% and this is 50%. So this is called median. If you divide the data into four equal parts, so these three are quartile. Quartile 1, quartile 2, quartile 3. So these are the three quartile. Similarly, if you divide the data into 10 equal parts, so you have to put 9 cuts, and these are called decile. Similarly, if you put the data, if you cut the data into 100 equal parts, so this is called percentile. So we are having all these concepts in central tendency. So let me show you how we can estimate all these things. So going back to the software, and we are having the monthly income, and we want to calculate all the central tendency measures of this monthly income, and go to analyze, descriptive, frequency, and go to this statistics. Okay, first of all, we want monthly income, scale variable, you can see, scale, statistics, and this is called central tendency. This is central tendency. And all these are the values are the quartile, percentile, and this is decile, if it is 10. So we have to select mean, median, mode, quartile. So we are calculating the 4 aspect. Continue. And okay. So you can see that the mean average salary is 50,000. Median middle value is 48. And most of the people, most of the employees are getting salary near to 39,000, like this. And let me show one more thing. I hope you can see the person in 25th position. So if let's say this is the data. So middle value is 48. And this is quartile 1. Quartile 1 is this. This is quartile 3. And quartile 1 and median are the same thing. Quartile 2 and median are the same thing. Quartile 3 is this. And quartile 2 and median are the same thing. So we are having all the values here. And after that, let's see one more thing. Go to analyze, descriptive, and explore. Now we are moving to the explore. Monthly income. And do nothing, just click OK. So very important concept you can see here. 5% trimmed mean. And 5% trimmed mean is 49,000. So initially you checked that the average was around 50,000. So we have tested that the average was 50,000. But when we calculated the trimmed mean, it is 49,200. It is approximately 1,000 less. So it means if you remove the outlier, higher side, both side actually, 2.5% from the left hand side, 2.5% from the right hand side, you left with the mean of 49,277. So sometimes this trimmed mean is more reliable as compared to the normal mean. So being today is the first day, so we are not going in much detail. And so the purpose of today's session is to just introduce you about the software. And we have covered the central tendency. So tomorrow I started with this level. And tomorrow we will discuss about the dispersion, distribution, and dispersion and distribution. I actually want to discuss in detail. So give a separate session on that. And distribution is very, very complicated concept nowadays. And then we will move to the outlier testing. So dispersion, distribution, and outlier will be covered in tomorrow's session. So I hope you will do practice tomorrow so that be familiar with the software first, and then we will move to much detail. So give me a minute.